Hi, my name is Kelly Swanson. I recorded a video today, this morning, and I was narrating it. It was a screenshot video, but I wanted to introduce it because it's about the picture that you see right here. Of course, it came across the news the other day, and it's PDS70. And the talk was, can an exoplanet have a sibling sharing the same orbit? And which is tantalizing in itself because we have a very similar uh, orbit with our sun, and we believe that there is another Earth, a ninth planet, um, but we have yet to find it. But our solar system ourselves is a pretty big space. We could have missed it, and we have Jupiter, which has a lot of Trojan moons sharing orbits, and it meets the polarity guidelines. When you have positive and negative rotating around uh, at a central star, sun, it makes a lot of sense. I would imagine one would be a positive, one would be a negative attractor. Um, but with that being said, I used the DARKLight UV-LUX filter to examine uh, this image right here. I downloaded the large TIFF version, and the ALMA is an amazing telescope, and it allows us to see deeper within some of the images that are processed outside of, such as the Hubble. So I wanted to present this to you, and this is a little bit more insight into the dark light filter process with astronomy, astrophotos. So enjoy. Hello and welcome everybody. This is Kelly Swanson, citizen scientist. I was looking at this particular image this morning, reevaluating what I was looking at inside here, and I decided to just throw in something different. I'm seeing in the center here a bit of strings. It's kind of a motion strings, and I'm seeing the formation portion within these dusty regions, which are pretty much large gas debris. And of course, this thing is making a ring because it's tremendously spinning. It's got spokes on the outside. So I decided to use the UV-LUX filter on this. The UV-LUX is one of the few filters that I use um, that I've altered the color frequency so that I can see in a UV pattern. Uh, it mimics the ultraviolet wavelength, and it's pretty good at determining whether there's a solid object inside or whether it's just bound energy producing that solid look. So I'm showing you the original, and I'm going to jump into where I'm at within the filter right now. So I'm seeing, of course, the center core, and I'm seeing this large, very large object here. But I want to show you, just staying within the confines of exposure with black and white. And as you can, gotta wait for it to catch up here. Okay, so as you can see, the green is flat, and the red is just ever so slightly bent upwards from here. Other than that, turning off the green, never touching the blue, produces this infrared slash UV particular formula that I discovered. So as we will let this thing catch up to what I'm doing, this is really slow whenever I'm working at it. So there are some smaller bits in here. The brighter the object, the more solid the object when it comes to this filter. So there is a very large object right here, but there's also bits and debris that are in rotation around this area up here. And the whole thing is rotating inside very quickly. You've got a formation that's being pulled in right here, and more debris around here. So as I move the black and white, and it's having to process in real time right now, so it runs kind of slow. But as you can see, the rotation patterns of what certain things are doing, you can see objects line up or light up and wrap around certain things. So there is an actual object up here at the top, as you can see, and it changes frequencies within a very small range. So seeing that tells me what that dark space is up there at the top. It's an object. It could be a small planet, could be a small dark sun. It's a negative object, meaning it has more subtractive power than positive power, and so it may be pulling in versus repelling. Like our planet does a little bit of both. When a high velocity asteroid or comet comes in, they will bounce off. I've noticed that only certain bits and larger bits, it's all a matter of negative and positive polarity within our atmosphere. Whether or not the keys to the kingdom come in and enter or not, or they skip off the atmosphere. So let's take a look again with this area within black. And then we'll move this around just to see what we're seeing inside here. So there is a very small emission area that's taking up a lot of glow within this area right here. This piece over here, which is negative, is rotating in tandem. I've seen that a lot. There's always a positive and a negative when it comes to these things. That's why in Sagittarius A and B, Centauri A and B, there's always a BB and an AA around, and in theory they're black holes. You've got a positive and you've got a negative. The positive is what we see as a huge star, and then the negative is what we see as an event horizon, about as bright as the star itself, overwhelming right next to it. One of the first filters I built was sun off, where I took a picture that NASA had taken up on the space station, and I achieved the ability to turn off the sun, the bright beam of the sun, and kind of point it backwards, kind of focus it back so that I could use it like a flashlight. And that ended up creating the backlight capabilities during the first year of producing these. So as I'm looking through here, I'm trying to find another object, and there it is. There's the little guy. So this, don't be alarmed by seeing squares. The inverse square law of cubism is very much in play. It's part of quantum spin, and it's very measurable. So we have a star forming right there, you can tell by the sharp plus sign right here on the dark area and the triangular wave and stuff. So this whole thing, you've got an object that's rotating around. This one's rotating this way, this one's rotating this way, and that's what's causing the these energy lanes, as I call them, to form. And it looks like a giant spinning piece. And this is a process I've seen a lot throughout our universe, throughout photographs from NASA and ESA and ESO and the new James Webb Telescope. So you can see these lanes, and yeah, there's an object right up in there that's moving around. Looks like a bunch of debris, forming a nice little energy piece. They look very much like comets, and they could have been at one time. They flew in too close to here, got caught, and started zinging around. And that happens. I've seen it happen in these photographs. It's quite amazing. So we do have an object here that's coming out. Looks like formation. Looks like another smaller object is coming out right here that's being formed. And this spin produces concentration. It gathers, as the spin is going, matter collects and begins a form of compression, which forms planets eventually. But we're talking millions and millions and millions of years. So what we're seeing in this is formation. This obviously was a star at one point. The triangular patterns and the way the energy is glowing off of it shows rotation patterns rotating. As you're looking in the picture, it is rotating counterclockwise. So it produces a smear to the top right and a smear to the bottom left. That's light. That's how it works. So let's continue on here, and you'll notice here in the point curves that I've split the frequencies up quite drastically. That's through masking. When you mask something, you can mask frequencies. So you can tell Lightroom what to do, what not to show, what to show, and by that combination of strengths, you can create focus. You can create turning things inside out, like we're getting ready to do here. So now we do see that there is a center star there. Oh, let's see. The frequencies are so precise, and it's so hard. You have to sit there and you have to. Oh, it's a double star. There's two stars. They're so close together, so that's what's making that. Wow. Okay, so we got 80, 78, and 75. So there's 76. Let's see if we can get it to 77. This is one of the reasons I wanted shadows and some of the other ones to have decimal points, so that you could really get precise in here. Try 77. No. 75. No. 76. No. How about 74? No. Which way do I gotta go? I gotta low? Oh yeah. Okay, so 73. Oh, it's one of these. Okay, so yeah. Alright, so shadow's not going to get us there. It's only going to show us what is there. So what we're going to do, get it in as close as possible there, and then we'll start adjusting. So there's this grid-like cubism that forms. You can see it right there. And when the energy, you've got quantum spin, okay, quantum level, galactic level quantum spin, and it produces such a ferocious spin, it pulls in from the corners. And this is part of the inverse square law. And there was a huge paper written on it and a symposium given about it with these grid-like patterns in our atmosphere. And I adapted that theory that if it's in our atmosphere and we're spinning around the universe and galaxies that we're in, then we're going to interact with that. And at some point it's going to slap us. So these patterns here, and I'll see if I can get this to zoom in a little bit. When you zoom in, the filters, because of the way they're masked, they will adjust the light that's shown within that small area. And the software will automatically adjust to it. It takes it a bit, but it's processing it. So let's wait for this thing to finish. If you can't see it, you should be able to see the little spinning thing there. Let's try shadow again. Now that we've adjusted black, let's see if we can get shadow to show us the stars. So, like some of the other previous photos I've posted, these double globus stars, they strap together. They hold each other, and then they start spinning and creating. Oof! There we go. One part of it. There's another. There's an emission. And you can see the roundness right there. There we go. There's one of them. And one of them is positive, and the other one right here seems to be negative. Or it could be even closer to it off of one of the spiral arms. I noticed that they tend to stick together. Kind of the way our bacteria in us join together. And they literally form an electrical bond. There's the one star. See the plus sign right there? Let's see if we can get. And there's another star, and there's more stars inside this thing, and they're spinning. Ooh, we got a little refraction there. Oh, look at that. So it's refracting the light inside this piece, and there is the main positive. So you've got a couple of stars in here that are forming together. One giant, massive, and it's pulling it in. And I saw this process occur in a smaller version inside one of the Messier black holes. As it's shooting out an emission, they took a picture of it in 2017, and then they took a picture of it, well, they took a picture of it in 2012, and then again later on in like 2017, and it had combined. It had joined and pulled in and evaporated the other object and pulled it in and became one bigger, brighter object. And I'll be showing you that in another video. So this is a really cool feature right here. And yeah, I know we were looking for orbital objects, and we have an object in here, and we have one really bright object here. We've got a negative over here in this area, and then we've got this massive piece right here, which looks like the early formation of a gas cloud, which is what they had thought was in this. And it chemically might be, but there are a lot of dark negative squares within this area, which shows me there's even more rotational objects. And you saw those a little bit when I was rotating. You see the blue objects spinning around. Those are solid objects. Those are, I'm going to save this one. That is a stunning picture. And we'll examine that later on. But this is, you can also see the blue outlining up here. It's really faint. These are really dark. There's stars that form inside and they spin around as well. And it's kind of like a spirograph. You remember those? Drag your pencil around and it creates all these geometric patterns. Those patterns exist in not just there, but like, Fibonacci patterns and different types of mathematical equation patterns. They all exist in nature, and I theorize that they exist outside here too, but we have somewhat of a control on our air atmosphere, but then again we don't, because it's an open air atmosphere. Things form on their own, and I theorize that out in our universe, in our solar systems, and out in a sort of non-oxygenated space with air, we have a multitude of matter that is both positive and negative and neutral, and that neutral bit hasn't reacted yet the way you would light a match in your air environment, and it would immediately start burning the air and light the match. And as long as you had oxygen and you had a combination of hydrogen and oxygen, and that fire is going to continue burning as long as there's an object to burn, which is the matchstick. The rest of the part will continue to happen until that piece of matter no longer has anything to react with. And it took that spark to create it. So all of these things go into the whole creation of things, because you got one thing turning into another, and you have, let's take it from here. I'm going to check out some of the other filters. One of the things that I like to do is I'll take the filter about as far as I can get visually, and then I'll start up another filter. So here's a more slightly tweaked version of the UV-LUX I call DARKLight UV. And as you can see up in the top of the screen, that object is there. It's emitting energy, as you can see, with that little blue aura around it. Those are energy waves. They flow like liquid. Dark Shell tries to put a wrapper and tries to show patterns. And it looks like that object up to the right there is moving inbound and finding a spot within the rotational patterns. You've got some other objects that are in pink up there in the square. In the center is the object. The square is just a pattern. And then you've got some small solid bits around here that are lighting up like small candles. Philo is a new functional infrared light object detector, and it's still in experimentation, so I tend to use it every now and then and just see what it can do under these particular frequencies, to kind of bring out details and find small bits of solid objects out here. Because, when we look at a visible photograph in visible light, we're seeing a ton of glare. And a lot of that glare really overpowers the initial image, and it kind of tricks you. It's like seeing a mirage. With that much energy emitting out a particular shape, you can't see that there's a circle in the middle sometimes. You think, wow, look at that big star with all those bars. And they're like, well, those bars are emitters, and they're shooting out stuff in such a velocity. Yeah, there is an object emitting a huge amount of energy. That's that little red star up there, red whatever object it was, and it's emitting one heck of an energy cloud. So let's see what Philo Auto will do. Now, Auto uses the AI and the masks. I usually turn them off, turn them on. It depends on what I just want to see, and see if the AI can find something. Maybe something I can't see that's just beyond reach. So we'll wait for this thing to spin up and Let's see what it can find. Wow. Did it really take us all the way back to what we were about? Ah, there we go. Whoa, we've got a very negative, that's what's emitting. Oh my gosh, that big glow is a small little black hole rotating around this thing. Holy moly, it's rotating around these stars. It can either be a black hole or a very big solid object, but because it's emitting such a huge red object right there, you can see how, and it looks like a burst of energy. Let's see where the hole shows up. Come on, baby, Daddy needs another black hole. I'm on an old Mac, just so you know, a Mac Pro laptop with an i7 quad-core processor. So it's powerful, but it's really old compared to like the new M1s. So the red dot's there. There's an emission spot. The black object. Oh, it took on. I wonder if it's going to process again. Go back to that blue stage. I've had this happen before. And this is why I keep experimenting with it, and I haven't released any of them because they, when you're dealing with frequencies, as you saw before, you move 1% past something, and it's not there no more. And that really is annoying, and it would be very annoying for, and it would probably prompt a support question like, why is this thing doing this? You know, this is science. Science is full of experimentation, and it's a journey is what it is. And when you discover something and you see something on screen, you better take a screenshot of it because it might be the last time you see it. I've had that happen dozens of times, and it's really, really annoying. Like just now, I didn't take a screenshot of that hole, and that object is there. Something's there. It's very massive and dense, otherwise it would not show up as black with that particular filter. Like this, for instance, is very dense space. So the whole thing as an object is energy inside here, but the mass around it is just dense, empty void. Man. Okay. So well, there it is. It's back again. We found it. Oh, we got it again. Okay, so I'm going to take a screenshot of that. So that bad boy's way up there. Now, this is also the purpose of, you screenshot these, and as long as you keep like the same screens while you're looking through here, you can stack those, and they'll give you a very unique frequency view of the object that you're looking at. Right now we're seeing a lot of energy, and Philo looks at objects, but it will see energy objects. Energy so strong that it makes waves. And as you can see here, the solid objects that we were looking at previously formed such a strong field of energy that they appear solid even to the AI, like a ball. And when you go and look at the original, that's the ball that we see in visible light. Those rings are energy spin lanes. That means that there are one or two objects in those lanes. There's an object in the black lane, and they're spinning, and they create these lanes. I've seen them countless times in photos of galaxies. They swirl up just like this. It's fun seeing these squares because eventually they round out and they become an oval galaxy, um, or something in between. These are fourth generation filters, anything with a asterisk next to it. Okay, we see a little blue spinner around there, and that bad boy is actually spinning in the proper counterclockwise direction. So as you can see the little blue over there, right over here, and it's creating an energy field that's so massive that it's pushing away the debris in here. And you can see the second lane up at the top there, in the top left. There's a dark spot, several dark spots that leaving spin trails and little spin lines. Those, just like a photograph in visible light where you see three moons, what that is those are trails. That means that moon is moving, and it's moving that fast. Or you see the same way we take a picture here on our planet, pointed up, and the Starlink passes in front of it, or an airplane flies in front of it. I made the mistake early on. I photographed this picture up in the sky, and I left the camera on and the shutter open, and of course it recorded an airplane flying over. I got all excited, and it wasn't. And another astronomer was like, "Dude, that's an airplane." He goes, "You can tell right there," and he took the time to explain it to me, and I'm like, "Oh, I feel like an idiot." So, early on, we all make these mistakes and stuff, and then we move on and we discover new things. Well, I've seen those same features inside NASA photographs, and it's the exact same thing, because when the telescope, it doesn't just snap a shot and it gets what it gets. The telescope, for those of you who aren't familiar with it, especially like the James Webb, it focuses on a spot for hours, days. It doesn't matter how long it stays, but during that time, it's going to record everything that it sees. Everything it sees and everything you can't see, or we can't see with visible light, or infrared, or even X-ray. It's a whole nother frequency out there, as you're seeing right now. So the energy is really tight under New Bright. Let's see what New Bright X will. Whenever I make an X, it's a combination of one or more filters. Give me the ability to try to make sense of what I'm seeing. And then sometimes I'll turn, as I'm making the filter, I'll turn on automatic while the filter's stacked, and it gives an even more elusive view. Wow, there we go. So we're seeing pixel smears where ejection is being spun around. Down at the bottom left, you see those dark shadows spraying outwards. That's just matter flying out like splatter. The object in the center is, of course, blue, and it's shaped because it is multiple stars that have collapsed together and are still spinning and still forming together. You have this object off to the right center. That's another star, and it's both positive and negative. It has combined and become an object that's spinning, and you've got this very, very large object that's rotating around the entire picture. And that spin from that yellow object going around and around and around is pulling in that one that's in the right center there, and has pulled it in, and it will eventually probably join or break up. If it's strong enough, it will stay separate in its own lane and eventually form its own spin lane. Right now, this is a very early formation. That looks good. Let's see what star controller can do. Yeah, that's some serious solid energy. There's the objects, the brighter, stronger objects showing up right there. Very small. This is called Sun Catcher. Let's see what this thing can do. This is one of the new ones I just developed with another photo. There it is. So that's the energy around this star that makes it appear like a sun. And that's exactly what it keeps tricking us in thinking. It's like, wow, look at this big old sun. And what's inside is a formation. Let's see what the auto does for it. Sometimes that bad boy really shows a lot, but oh, there we go. Very nice. Even more debris, even more energy lanes, and a tail object that's caught spinning around, which is off of a corner, so it's one of the stars. And these global stars that I've talked about in previous posts, they shed their tails. As they're spinning, the spindles or the star rays break off, and it starts shaving them down into a narrow circle. And these squares get formed, as you've seen, but the tails break off. As they're being squeezed out of the corner gets sharper and sharper and sharper, and then it detaches and spins off and does its own thing. And then VIN focus, yep, boy, that's a big object up there at the top. So again, a lot of spinning going on. We could stop at any one of these and just start adjusting. If you wanted to see some different looks in different areas, you would see things moving. And when I'm moving this, there's a little blinky going on right there, and that's about it. But it will adjust in a second as it catches up and processes that. And sometimes it does just that, absolutely nothing. If you really want to see stuff move, you can go in over here and target like an area. Yeah, did you see that? You can target an area and adjust it, and it will move the point curve up or down, and it'll allow you to oh, there's our little object right there, and it is a star. Capture that. So this gives you a little bit more info on DARKLight and its capabilities, and why you see some of the things you see here and what exactly they're doing. And yeah, us astronomers, we got to go to school again, because this is a whole new world with DARKLight. And I thank Sir Isaac Newton for writing his book Optics, because I used his formulations and his studies of prisms and bending light and all that good stuff. He didn't just invent color theory, people. He invented a whole different frequency of seeing with multiple layers of colors and multiple layers of black and white light, and using prisms to peer into one another and point multiple prisms at each other and see light cancel out, and all these other fantastic experiments that he did. And it was, he wrote a lot of letters to other people too. I read a couple of these letters, and people were like, are you sure you want to do this? And, you know, it was very, very interesting to read, just to kind of put my mindset into his mindset and vice versa, to see, you know, what would I do? You know, what would Isaac Newton do? And so I just kept working on this. I just kept, as you've seen in my posts, I'm constantly, I don't mean to berate anybody. I have to keep reminding myself, no one has ever seen this stuff before. I certainly am experimenting and seeing new stuff every single day, like what we just saw together here for the first time. These small stars are powerful. And once they get to spinning, they get to creating. And I'm looking forward to working with the best and the brightest on our planet around the world to share their information with me and me to share my thoughts and information with them, and together we'll move human understanding farther along, even still. Uh, the way all the greats, we got electric cars all the time now. We've got we're getting ready to have flying cars here pretty soon, which is something I thought I'd never live to see. But VTOLs are real, they're being used, and this science of lift and science of electrical storage and energy will all benefit us later on, and as long as we can keep our wits about ourselves and not interfight, because we are probably the most interfighting species on this planet. And we've got to chill out. We've got to look at this and not be afraid of it. This is what made us. If you look at some of the objects that I've seen, and then you look in a microscope, you'll see duplication. And quantum duplication is real. And we are just a small little fragment in a very big world right now. So I'm glad you guys watched this. I hope you learned something, and I will continue to make more videos and keep posting images and everything out there. So you guys have a wonderful day. Don't take things too seriously. Smile at everybody. Have a great day, folks.